warriors, welcome to yet another power packed session. We will actually do matrices and determinant today. But before I start any further, do let me know whether I am perfectly audible and visible. Yes. Okay, all right. Yes, I was a little unwell and I'm still suffering with viral infection. So my energy might be a little lower today, but from learning point of view, it will be on point. I have designed this session in such a way that you will get maximum advantage in your upcoming JEE Main April attempt. Okay, but I can clearly see that there is some camera angle is not that great. So I'll take a minute. I'll call my team to fix this camera angle. Okay, all right. Yes. Camera angle. This is getting all right, let's begin. Yes. Okay. Shall we start without wasting any further time, right? Because the sessions were getting rescheduled and all. So we'll start the session right away. But before that, let me tell you the agenda of the session. So we will start matrices and determinant from the proper definitions and all the properties. Along with that, meanwhile, we will be solving all the important PYQs, whether they are from 2024, 2023, 2022, 2021, 2020. Last 5 year important, all the important PYQs along with some very useful shortcuts which will help you in your upcoming JEE Main April attempt. Are we ready? Yes. Are we ready? All right. Are we ready? Okay. All right. Yes. We'll start the session now. Okay, so let's start with the basic definition. What is matrices? And you are aware that matrices and determinant is a high weighted chapter. And you know what? To all the JEE aspirants, this chapter is a must do chapter because it is an easy kill chapter as well and high weighted chapter as well. And along with that, to study matrices and determinant, you don't need to depend upon another previous chapter. There is no prerequisite. So every student should do this particular chapter, right? Okay, yes. And some of you were starting, yes, definitely it is from scratch. AOD, we will study AOD as well. Do not worry about that. Ma'am, this session will be useful for witty as well. Yes. This session is absolutely aligned with your witty examination. Okay. All right. Yes. We will start from scratch. We will solve all the PYQs as well. So you know what is matrices and what is determinant. Shall we understand what is matrices? Difference between matrices and determinants. So matrices is nothing but the arrangement in a rectangular format. As you can see that matrices is like this. The representation is like this. Okay. It is set of mn numbers arranged in the form of rectangular array of m rows and n columns. Right? So matrices is an arrangement. It is not at all a numerical value. But what about determinants, ma'am? So determinants is nothing but if you solve determinant, you can get a numerical value. So determinant is nothing but a numerical value. But matrices is not a numerical value. That's the basic difference. Okay. Now let us understand. So over here we call this as row. So there are some students who might get confused that ma'am, I always tend to forget that what is row, what is a column. So this is your horizontal. This is your row number 1. This is your row number 2. This is your row number 3 and all the way up to row number n. And what about this? So vertical are columns. So column 1, column 2, and you know what? So this will be column number n. This is row number m. Okay. So here you can see that there are m rows, right? 1, 2, 3 and m. So m rows are there, right? Number of rows. Who is going to tell me number of rows? So number of rows is equals to m and number of columns is equals to n. So m cross n is the order of this particular matrix. Okay. All right. we'll try to finish this session in 2.5 hours. Okay. So this for 2 chapters, high weighted chapter, come on, 2.5 hours. So we are going to need. Okay. And if you have not liked the session, please do like the session and share the session among your friends, your fellow JEE aspirant, so that we can get maximum interaction in the session. Okay. All right. Yes, yes, yes. All right. Now, order of the matrix. So we all know what is the order of the matrix. So if it is having number of rows m, number of columns is n. So m cross n is the order of the matrix, and the element of the matrix is represented as aij. Acha, I have a question. If I have, okay. So if I say A32 is the element of a matrix. Can you tell me what will be the position of this element? If A32 is the element which belongs to a matrix, can you tell me the position? Right? So over here, 3 is representing row and 2 is representing column. That means it is sitting in 3rd row and 2nd column. So row 1, row 2, row 3. And C1, C2. So can you clearly see this will be the position of my element, right? 3rd row, 2nd column. So if I say Aij, it is the element sitting in ith row and jth column. That's how we represent it. Okay, that's how we represent it. Is it clear? Is it fine? Okay. All right. I'm super duper happy that you are aware about it. Okay. All right. Okay. Now what is a row matrix? So row matrix, ये क्या लिख दिया? Row matrix. It is row matrix. Okay. All right. Row matrix means a matrix which is having single row. Okay. I don't care about the columns. I don't care about how many columns are there. But row matrix is a matrix which is having a single row. So can you see this is having row 1? But how many columns? C1, C2, C3, C4. 4 columns, 5 columns, 7 columns. In fact, 1 column is also allowed in this. Okay. All right. Yes. Now column matrix. So column matrix, can you see it is having single column C1. But how many rows? Row 1, row 2 and row 3. Okay. All right. Yes. Clear. So so the order of this will be 1 cross 4 and the order will be 3 cross 1. Okay. All right. You can expect 2 to 3 questions from this chapter. So I would say 12 marks from this chapter, right? 8 to 12 marks you can expect from this chapter. This is among the high weighted chapter. Okay, so can you tell me the answer of this particular question? Who is going to tell me? If a matrix has 8 elements, then how many matrices are possible? If a matrix is having 8 elements, okay, all right. So 8 elements, that means it can have 1 cross 8 or 8 cross 1, right? 8 can also be expressed as 2 cross 4 or 4 cross 2. And that's it, I guess, right? That's it. So 4 is the correct answer. Yes. 4 is, yes. Absolutely. So what I'm trying to say over here is matrix is having 8 elements. How many matrices are for? 1 cross 8 means 1 row. And how many column? Column 1, column 2, all the way up to column 8. This is first. Second is row matrix, right? So basically we are column matrix. So 1 column and then we are having 8 rows, row 1 to row 8. And then third, we are having 2 cross 4. So 2 cross 4 will look like this, 2 rows, 1, 2, 3, 4 columns. And we are having 1, 2, 3, 4 rows and 2 columns. So this is the fourth one. That's it. Yes. Okay. All right. Clear. All right. Yes, Mahesh, we will actually talk about it. When the time comes, we will talk about it. Trust me, trust is a process. Okay. At one go, I can't tell you what is the deleted proportion. Are we going to cover that? Are we going to cover the reduced syllabus? So we are going to do that based on the behavior of NTA in January attempt. The session is like that. The session is completely depending upon what behavior NTA has shown. So if they are asking from deleted syllabus, all those portions we will cover. Okay, that's it. Because we want marks. We want high percentile. Okay, all right. Yes, all right. Now equal matrix. What are equal matrix? So basic equal matrix means order should be equal and the corresponding elements should also be equal. So order is equal and corresponding elements should also be equal. So if two matrix, this is M cross N, this is P cross Q, so M will be equal to P, N will be equal to Q, and all the corresponding elements should be equal. As simple as that. Okay, all right. Yes, different matrices of same order may exist. Definitely order is same, but the elements are different. That's why these two matrices are different. Okay, all right. Yes, 2025 aspirant definitely can watch it if you want to. Now what is a square matrix? When the number of rows and number of orders becomes equal, we call it as a square matrix. I hope that this is clear. Now diagonal matrix. Okay, now this part is my favorite. Hold on. So diagonal matrix means that, okay, diagonal matrix means that the non-diagonal elements should be equal to 0. Listen to me carefully. What did I say? Diagonal matrix. What is a diagonal matrix? Understand the definition. The non-diagonal elements of a matrix should be equal to 0. So can you see the definition? Aij is equal to 0 whenever I is not equal to j. So whenever I is not equal to j, what does that mean? Acha, okay. What happens when I is equal to j? For the clear picture, let me just make a 3 cross 3 matrix. So this is A11, A12, A13, A21, A22, A23, A31, A32, A33. Can you see I not equal to j means what all elements? I not equal to j means what all elements? So this and this. Okay, this. Can you see all the non-diagonal elements should become 0? Then only we call it as a diagonal matrix. Okay. Okay, all right. Let me just ask you, now that you have understood this, let me just ask you one thing, that, okay, is this a diagonal matrix? Yes or no in the chat box. Is this a diagonal matrix? Yes or no in the chat box. Is this a diagonal matrix? Yes, Tanishka. Okay, I'll give you an answer. Okay. Yes. Okay. Abhishek. Yes. Null matrix. Yes. We will come to that. Okay. Okay. AG Tumblr is saying no, ma'am. This is not a diagonal matrix. Game Over Tamil is saying yes. It is a diagonal matrix. So somebody is saying, okay, few people are saying it is a null matrix or zero matrix. Okay. So I am getting a mixed reaction. Some people are saying diagonal, some people are saying zero. Okay, so this is definitely a diagonal matrix. Definitely a diagonal matrix because it is satisfying the definition of the diagonal matrix. So definition says, understand the definition. Definition says that it should be a square matrix. Is it a square matrix? Yes, ma'am. After that, the definition is saying that for I not equal to j, that means we will only talk about non-diagonal elements, which are these elements. 1, okay, and this, and we are having these two, and we are having these two. So are they 0? Are all the non-diagonal elements 0? Yes, ma'am. So that's it. It is a diagonal matrix. What does that mean? That yes, null matrix is also a diagonal matrix. Okay. And how do we represent it? So sometimes, because we know that non-diagonal is 0, we know that non-diagonal will become a 0, right? So we only write like that, diagonal, we only talk about the diagonal 2, 3, 5. right? A is equals to 2, 3, 5. Why? Because we only talk about diagonal 2, 3, 5. So now we can insert the diagonal and rest of all the elements would be 0. Okay, right? So how do we write it? We write it diagonal 0, 0, 0. That means your diagonal is 0 and non-diagonal is also 0. Okay. Yes, diagonal elements are clear. Now scalar matrix. What is a scalar matrix? Yes, a diagonal matrix having same element in the diagonal. Okay, what is a scalar matrix? Understand this. Now for a scalar matrix, we can't have 0 in the diagonal one. For a scalar matrix, we cannot write 0 in the diagonal. Okay, so but all the elements should be same. So basically, that's how we write A, 0, 0, 0, 0, 0, 0, where your A cannot be equal to 0, right? A cannot be 0. This is not a scalar matrix. This is definitely not a scalar matrix. Why? Because for a scalar matrix, your A cannot be equal to 0. So this is definitely not a scalar matrix. Okay? All right? Okay? Okay. Now unit matrix. So unit or identity matrix is a special case of scalar matrix. Listen to me first. Okay? I am trying to explain you. Scalar matrix. So unit matrix or identity matrix is a special type of scalar matrix where all the diagonal elements become exactly 1. Can you see 1, 1, 1? So a scalar matrix having diagonal elements as 1 will be your final answer. Okay? Okay? Clear? Scalar and unit matrix are clear, I guess. Okay, now let's talk about transpose of a matrix. Transpose of a matrix. Okay, so very simple. In transpose, what do? We just interchange rows and columns. So if we are having this matrix A, row 1 is AB, row 2 is CD, and row 3 is EF, right? Now if I take transpose of it, row 1 is AB, here column 1 would be AB. Row 2 is CD, column 2 would be CD, right? Row 3 is EF, column 3 is EF. I hope that this is clear. Okay. Yes, Tanishka Pandey, you are absolutely right. That's what unit matrix is a type of scalar matrix only. Yes, identity matrix is a type of scalar only, right? It is a part, like it is the type of scalar. Okay. Okay. So now can you see that number of rows and number of columns are interchanged? So over here, can you see this is n cross m? Now A transpose will be m cross n. Clear? Yes, yes, yes. Now some properties of transpose, very important. The moment you take A transpose and then if you again take the transpose, that means A transpose, it will become the original A. It will become the original A. Okay, all right. Now A plus B whole transpose. A plus B whole transpose will be equal to A transpose plus B transpose, right? Now this is very, very important. K times A whole transpose. Okay. So now K is stuck in the transpose. We can take this K out and this K, nothing will happen to this K. So we can take this K out. K is a constant, by the way. So it will be K times A transpose. So basically 3A transpose will become 3A transpose. This is the third property. I hope that this property is clear. Okay. All right. Now AB whole transpose. By the way, this is a reversal law. Reversal law. Reversal law. AB whole transpose is equals to B transpose A transpose, right? And ABC whole transpose will become C transpose B transpose A transpose. Can you see the reversal law? This is actually very, very important. These two things are very, very important. Okay. And one more law. Suppose you have to take A cube transpose. So what you can do is this power and transpose can be interchangeable. So it is A transpose whole cube. Okay. All right. Yes. So we have actually, yes. For matrix now, I always say this. For first 20 minutes, 25 minutes, we have to study theory and then we will get into question, because the theory part, the definition, the terminologies are very much, right? Terminologies are very much. A huge theory based chapter it is. So that's why we have to keep that patience and then we will solve all the PYQs. But matrices and determinants is absolutely easy chapter, a little bit theoretical, and then we will talk about the problems. Okay, so have patience. Okay, we are going to solve all the type of questions. Okay, all right. Now minors and cofactors. Okay, so how we add matrices? Yes, let's talk about how do we add matrices. Suppose we are having A 0, 2, 1, 3 and we are having B which is 1, 3 minus 1, 0. So how do we add any matrix? We just have to add the corresponding elements. So 0 plus 1 would be 1. Okay. 2 plus 3 would be 5. 1 minus 1 would be 0. 3 plus 0 would be 3. But we need to make sure that A and B both should be of same order. Otherwise we won't be able to add. Okay. Are you getting? The moment you add these two, you will get A plus B. The corresponding element we will add or subtract. But you have to understand this nicely, that both the order of both the matrix, can you see 2 cross 2, 2 cross 2? Then only we can add, otherwise we cannot add both the matrix. Okay. Now minors and cofactors, we have to know a little bit to start the determinants part. The basics of determinants will start. Okay. So what is a minor? Let's understand this. For a 3 cross 3 matrix, if a row and column passing through element, okay, our determinant is okay. Let me just show you practically. So what I'm trying to say is we are calculating minor, we are going to calculate cofactors. Okay, and then we will talk about the determinant. What is a determinant and how do we calculate determinant? Okay, yes. So minor, cofactor and determinant. Let's understand. So first of all, every element you are seeing in this matrix is having a minor and having a cofactor. So we will talk about minor of A11, we will talk about minor of A12, minor of A13, minor of all the elements. So minor of A11, how do we calculate? So we need to hide the first row, hide the column 1. Column 1 and first row will be hidden. And now we are left with this. This is nothing but a 2 cross 2 matrix. Can you see? 2 cross 2 matrix, or you can call it a determinant as well. So we are here. The minor is nothing but, okay, minor M11 will be nothing but determinant of this. So A22, A23, A32, A33. Okay, this is your minor. Okay, M12, what will be M12? Let me just tell you what is M12. Right, so M12 is hiding column number 2, hiding row number 1. Can you see A12, A23, A31, A33? That's how you calculate. Now M12, how do you calculate? So A33, A21 minus this cross this, minus A23, A31. What about this? A22, A33 minus A23, A32. Okay, this is your minor. Okay, what is a cofactor? Now cofactor is exactly, the value is exactly similar to your minor, but with a little bit of sign change. Okay, but with a little bit of sign change. So this is the formula of minor and cofactor. How to convert minor into cofactor? So suppose you are having M11. Now you have M11, M12, M13, M21, M22, M23, M21, 31, 3, 2, M, 3, 3. Right? You are having all the values with you. Now 1 plus 1 will give you even number. Even number means positive. So M11 will be equal to C11 positive. Now M12, okay, M12, sorry, let me write it this way. C11 is equals to M11, okay, plus. Now what about C12? So C12, for C12, can you see 1 plus 2 is odd, 3 is odd. So negative of M12, like that. C13 will be plus because 3 plus 1 is 4. So this will be M13 and so on. That's how we calculate the cofactors. Okay, so these are the minors and cofactors. Do you want me to take one example and show you? Taking one example and showing you how to calculate minor and cofactor. Okay. Okay, let's talk about this first. Yes, so this is determinant. 2 cross 2 determinant. How do you find 2 cross 2 determinant? So suppose you are having 2, 3, 4, 5. So 5 2s are 10 minus 4 3s are 12. So answer would be minus 2. As simple as that 2 cross 2 determinant, how to expand it. Okay. Can you see minus 12 and then you have, so minus 12, then minus sign, then minus 21. So minus 12 plus 21 is equals to 9. That's how you expand 2 cross 2 determinant. Now, how do you open 3 cross 3 determinant? Okay. So to open 3 cross 3 determinant, you have to understand that you can open 3 cross 3 determinant or expand 3 cross 3 determinant by 6 ways, 6 different ways. What are those ways? So you can expand it row 1, row 2, row 3, row wise. So we've got 3 rows, so row wise, and 3 columns, so column wise. Okay. Now let's start with row 1. We often expand the determinant with the help of row 1. Okay. So what is row 1? This is your row 1. So that will be A11 into C11. Can you see A11 into cofactor of 1, 1? Then you've got A12. So plus A12 would be equal to C12. And then you've got A13, C13. Right? And C12 can be replaced by M12 because they are negative. So C12 will be minus M12, but C11 and C13, these two are same. So C11, M11 can be replaced. C13, M13, same sign, same value. Okay. All right. Yes. Okay. And the moment you expand 3 cross 3, you know, 3 cross 3 determinant, how do you expand? Okay. And one of the application of determinant is nothing but how to find area of that triangle formed by 3 vertices. So suppose you are having 2, 3, you are having 3, 2, and you are having 1, 1 as 3 vertices, and you need to figure out area of this triangle. How do you do that? By applying this formula. So 2, 3, x1, y1, 1, and then 3, 2, x2, y2, 1, and then 1, 1, 1. Determinant close. Please do not forget to apply the modulus. This will be your area of that determinant. Okay. All right. Yes, I hope that this is clear. All right. One very important property, and I will tell you that how to differentiate between matrices and determinant as well. So suppose I am having this matrix. First of all, let's talk about matrix. And if I have to multiply this matrix by 3, so 3a will be, so 3a. Now 3 will get attached to each and every element. So 3 2s are 6, 3 3s are 9, right? And then we are having 3. 3 2s are 6, 3 4s are 12, 7 3s are 21, 0, 3, 3 2s are 6. That's it. So can you see multiplication of scalar with a matrix? Multiplication of a scalar with a matrix. Can you see it? Right? So each and every element I'm going to multiply. But that's not the case with determinant, guys. Determinant, we can't do that. Okay, so ma'am, what do we do in determinant if I have to multiply any constant in determinant? So you have to select either a row or a column. So how many options do you have? You have 6 options. Row 1, row 2, row 3, column 1, column 2, column 3. Select any of the rows or column and attach that k to that row or column. So suppose in here I have selected row number 1 and I will now multiply this with row number 1, KA1, KB1, KC1. Okay, all right. And you know what? Just think about the reversal thing as well. How do you take common in a determinant versus how do you take common in a matrix? Yes. So taking common from a matrix is how do you do that? You have to take common from each and every element. But taking common from a determinant, so you have to take common from single row or single column. Okay. All right. Yes. All right. Let's solve this question now. Let's solve this question. Okay. Okay. Bij is equals to this. Bij. Okay. Aij, Bij are elements of a 3 cross 3 respectively. Okay. All right. So basically they are talking about 2 determinants. I can clearly see 2 determinants, right? First one is del 1. Can I form del 1? Yes, absolutely. Determinant. Okay. So determinant. So this will be A11, A12, A13, A21, A22, A23. Okay, 2, 3. A31, A32, A33. Determinant close, right? This is your del 1. What about del 2? So del 2 is actually having B11, B12, B13, B21, B22, B23 and B31, B32 and B33. It is given that del 1 is 2. So this del 1 is nothing but 2. It is given. Now one more thing which is given to us, Bij is equals to 2i plus j Aij, right? So now I can convert this. What will be B11 from here? Can you tell me? B11 will be 2 raised to power 2 A11. So 2 square A11, right? Over here 2 cube A12. Over here we are having 2 raised to power 4 A13. What about this? So 2 cube. What about this? 2 raised to power 4. So 2 raised to power 4, 2 raised to power 5, 2 raised to power 5, 2 raised to power 6. And this will be A21, A22, A23, A31, A32, A33. Right? All right, all right. Okay. We will study everything. Don't worry. Hai na? So 2 square. Can you say that 2 square we can take common 2 square from row number 1? From row number 1, I want to take 2 square common. Right? So if I take 2 square common from row number 1, it will be gone. 2 square, let me write outside. And this will be 1. This will be 2 square. That's it. Now what about row number 2? So from row number 2, I am taking 2 cube common. So this will be gone. This will be 1 and this will be 2. From row number 3, I am taking 2 raised to power 4 common. This will be gone. This will be 1 and this will be 2. Right? So that's it. Now think about the column wise. Column wise think that over here, this is nothing but A11, A21, A31. Column wise we will think. Now column wise I can clearly see this is 2 raised to power 1, 2 raised to power 1, 2 raised to power 1. So column 2, from column 2 I am taking a single 2 common. So I am having one more 2. And from column number 3 I am taking 2 square common. So 2 square is also with me. And can you see this is nothing but delta 1. This is your delta 1. Delta 1 is 2. So now you can just calculate this. So this whole will be gone and this will become 2. So this is 2 square. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. So delta 2 value is becoming 13. Yes? Absolutely right. Game over, Tamil. Yes, yes, yes. All right. Yes, the 2 raised to power 13 will be the final answer. Okay. All right. Clear? Give me a big thumbs up if it is clear to you. So now we are having a JEE Main previous year question. Okay. Similar type question, but a little bit with a twist. Come on. It's a JEE Main question, right? Okay. So now A is this and B is this. Okay. Aij, Bij. Okay. So again, two matrices are given to us and we are having this. Again, a similar type of thing is given to us if the determinant of B is also given to us, 81, and then the determinant of A is what we need to figure out. Okay, so similar type of question. Similar type of question is given to us. B, we are having this. Determinant B is given to us, 81, right? And determinant B, if I write down, will be, okay, so that will be B11, B12, B13, B11, B12, B13, B21, B22, B23, and B31, B32, B33. This is your determinant B. What about determinant A? What about determinant A? So determinant A will be nothing but again same. A11, A12, A13, A21, A22, A23, A31, A32, A33. Right? Yes? Clear? Now let us understand this. Bij. Can you notice a slight difference over here? This is Bij, this is Aji. This is Bij, this is Aji. Okay, all right. So over here, if I wish to calculate B11, what would that be? What will be B11? So this is 3 raised to power 0 and we are having A11. Okay, now B12, who is going to tell me? So B12 will be A21 and that would be 3 minus 1, 3 raised to power 1, and B13 will be 3 square A. Okay, so A31. A31. Can you see this difference over here? Yes? Okay. So right now, can I just start substituting the values in determinant B? Can I just start doing that? Rather than writing it over here, let me just do that. Okay. So B11, can I erase B11 and write 3 raised to power 0? Okay. So B11 would be 3 raised to power 0 A11. Okay. All right. And what about B22? Let us first fill the diagonal elements. What about B22? So that will be same, right? So 3 raised to power 2 A22. What about this B33? So B33 will be 3 raised to power 3 plus 3, 6, 6 minus 2, 4. So 3 raised to power 4 A33. Okay. All right. Clear? Okay. Slowly we are going. Now what about B21? Who is going to tell me B21? Or let us talk about B12. So B12 will be nothing but use this. 3 raised to power 1 A21. 3 raised to power 1 A21. Right? So 3 raised to power 1 A21. Oops. Are you understanding this? This is A11. This is A21. And what about this? So this will be replaced by A31 now. A31. A31. And what about this? So 3 plus 1, 4. 4 minus 2. So 3 square. Okay, now I understand the pattern. Now I understand the pattern. I can just write each and every element. Let's just delete it. So over here, I'll be writing A12 and here A13. Can you see the transpose matrix is getting formed or transpose determinant is getting formed? And this is 3 raised to power 1, this is 3 raised to power 2. And this is 3 raised to power 3, A over here 2, 1, 2, 2, 2, 3. Right? Yes, absolutely got it. How I got determinant B. Again, now we need to do the same thing, right? I'm deleting this. Let's do the same thing now. Okay, which we did in the previous question by taking out common, right? Let's take common. So can you see that from, okay, row number 2, this is left 3 cube and this is A32. From row number 2, can you guys see from row number 2, I can take a 3 out. I can take a 3 common from row number 2, right? So 3 out from row number 2. This is determinant B and I am taking a 3 common from row number 2 and 3 square common from row number 3. Right? So I'll be left with what? So this is A11, A12, A13. Okay? And from row number 2, I have taken 3 common. So that would be A12, A22, a 3 is gone and 3 square, A32. From row number 2, I have taken 3 square common. So A13, A23, right? And 3 square, A33. This is it. Now what can I do? And this is your 3 and 3 square. Now can you see from column number 2, I can take a 3 common. And from column number 3, I can take a 3 square common. All right. And now can you see that this is nothing but your, okay, determinant A. This is your determinant A. This is your determinant A, right? This is nothing but your determinant A. Determinant B is given as 81 and this is 3 square, 3 square, 3 square. So 2 plus 2, so 3 raised to power 6 and that will be determinant A. I know that this is a transpose of that determinant, but you know that property that delta is equals to delta dash. So that is not, absolutely not a problem, right? The transpose and its determinant is A, right? Okay. So over here, can you see what will be the answer of this particular question? So this is 3 raised to power 4, right? 81 is what? 3 raised to power 4 upon 3 raised to power 6 is nothing but determinant A. So you are going to get determinant A is equals to 1 by 9. Right? Yes? Okay. All right. Cool. Determinant A is nothing but 1 by 9. Okay. If it is not visible, let me just write it a little bit above. So what was the procedure? What was the procedure? Over here, we wrote determinant B and determinant B in terms of elements of A, right? And once we are done, we have applied that property. You can see clearly we can take 3 common, common, common. And finally, the agenda is to form a determinant A over here. Now, determinant B, you know 81. Determinant A, you wish to calculate. Just plug in the value, you will get the answer. Okay. All right. Yes. Okay. So this is the easiest way. So over here, can you see this determinant B is this? B11 is 3 raised to power 0. B12 will be replaced by this. B13 replaced by this. Then B21, B22, B23 and complete this. Now, can you see from row number 2, 3 raised to power 1 is out. Okay. From row number 3, 3 square is out. And from column number 1, 3 is out. From here, 3 square is out. So 1, 3, 1, 3 square. And then again 1, 3, 1, 3 square. And you are left with determinant A that will equal to determinant B. And now from here, you get determinant A is 1 by 9. Okay. All right. Yes. Done, 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 done. Clear? Okay. Now another property let's understand. So over here, a determinant can be splitted into sum of 2 different determinant. Or you can say 2 different determinant sum can be combined and written into one determinant. How do we do that? So in here, can you see that you can do that only along either a single row or a column? Either along a single row or column. So over here, can you see that row 2 and row 3 are same? But we are doing with respect to row number 1. So row number 1. Now this row number 1, can you see A1 plus X? So A1 will be in this, B1 will be here, C1 will be here. Then we have X, Y, Z. X, Y, Z will be here. But understand this, realize this, row 2 and row 3 throughout remains same. Okay? Row 2 and row 3 throughout remains the same. Yes, Vikram, absolutely right. Okay. All right. Now, it can be done via column wise as well. You can see column 1. So yes, A1, A2, A3 over here, X, Y, Z over here. Here, column 2 and column 3 are same. Okay. And over here, can you see that this determinant can be splitted into 3 different determinants as well. So it is actually, you can do it for n elements. And it is not limited to 3 elements. You can do it for n elements. A1, x1, y1. So this is A1, x1, y1. A2, x2, y2. A3, x3, y3. Okay. Okay, now we don't use this property to split. We never use this property. We rarely use this property to split, to break into 2 determinants. Rather, we use this property to combine the determinant. Okay, rather than using it this way, na, what do? So we have 3 different determinants and we try to combine this. And from here to here is important. Here to here is not that important. Okay. All right, so can you see this? Now I have this 1 square. Can you see that these are the n determinants? And a very good observation is row 2 and row 3 throughout is same. Row 2 and row 3 throughout is same. But row 1 is different. So can you tell me just how do I write it over here? So 2, 3, 4. 2, 4, 5 will be similar. And the first element of row 1 will be 1 plus 2 plus 3 plus 4 and all the way up to n. So 1 plus 2 plus 3 and all the way up to n will be the first element. What about this? 1 square, 2 square, 3 square. So 1 square plus 2 square plus 3 square and all the way up to n square. And this is 1 cube plus 2 cube and all the way up to n cube. You know all the formulas from sequence and series, right? Don't you? You know all these 3 formulas. So the first one is sigma n, which is n plus 1 by 2. Second one is sigma n square, n plus 1 to n plus 1 by 6. And sigma n cube is n plus 1 by 2 whole square. You remember all those formulas, right? So yes, this is how we are going to replace. So this is the final determinant. Just replace by first, second and third. Okay? All right? Yes, yes, yes. Give me a big thumbs up if you've understood this. Okay. All right. So now whenever you have to apply summation in that, okay, I'm talking about the integration. We are not studying calculus. Summation in a determinant, okay? All right. So whenever you have to apply summation in a determinant, right? How do we do that? How do we do that? Summation in a determinant. Because I know that, yes, I know that summation, the moment you see sigma, you guys are scared. You're like, what is this? Okay. All right. But now summation in a determinant will scare you more. But I am here. Don't worry. Do not get scared. So over here, the moment you see sigma is there, r is equals to 1 to n. always understand that sigma will be applicable to only those elements which are related to R. Okay, so sigma will be only attached to the row number 1 because only row number 1 is having sigma. Okay, and rest rows will remain same. So can you see only the first row is having sigma, 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 that's all. Okay, no other element is having sigma. By the way, also it is also either a row wise or column wise. Okay, all right, so let us understand with the help of the example. So this is your example. So can you see that delta R is given as this and we are looking for sigma delta R. That means we are having sigma and sigma of, before this determinant. So what will happen with this sigma? This sigma will go inside, but can you see this column 2 is completely in terms of n. Column 3 is also completely in terms of n, right? But only the column number 1 is having all the elements related to R. So the sigma will get attached to R and over here and over here. Okay, all right, yes. So shall we start? Shall we start? है ना? Let's start solving. So sigma delta R, R is equals to 1 to n, will be equal to the sigma will go inside. So this will be sigma R, sigma 2 raised to power R, sigma 3 raised to power R. Row, column 2, column 3 will remain same. I'm not gonna do the hard work and it will be same. Okay, I will only focus on the column number 1. What is sigma R? Who is going to tell me? So sigma R, R is equals to 1 to n is nothing but n plus 1 by 2. What about sigma 2 raised to power R? So that again R is equals to 1 to n. Who is going to tell me 2 raised to power 1, 2 raised to power 2? So this is going to be a GP, right? So first term, you know this formula A, R raised to power n minus 1 upon R minus 1. So 2 raised to power n minus 1 upon 2 minus 1. So 2 raised to power n minus 1. Okay. So this will be replaced by 2 raised to power n minus. Now let me just start replacing it. N plus 1 by 2. 2 raised to power n minus 1 and sigma 3 raised to power R. Who is going to tell me sigma 3 raised to power R? So that will be 3 raised to power 1 plus 3 raised to power 2 and it will become 3 raised to power n minus 1 by 2. So 3 by 2, 3 raised to power n minus 1. This is your column number 1. Let me just copy column number 2. n plus 1 for 2 raised to power n minus 1. 3 raised to power n minus 1. And over here we are going to write the same thing. Can you now see? Why are you not telling me the answer? The answer is right in front of you. Okay. Can you see that column number 1? If I multiply 2 in the column number 1, I'm gonna get this, right? If I multiply 2 in column number 1, I'm gonna get this. If I multiply 2 again in column number 1, I'm gonna get this. That means 2 columns. Column number 1 and column number 2 are exactly proportional to each other. What happens to a determinant if 2 rows or 2 columns are proportional to each other? It becomes 0. It becomes 0. All right. Why are you not giving me this answer? Let me just tell you the property or what? Don't you know this property? When 2 rows and 2 columns are now I am saying now you will spam me with 0. You have to answer previously. Okay, now I have given you the answer 0. What happens when 2 rows and 2 columns are proportional to each other? Okay, Yes, Supriya is asking how do you distribute sigma inside the matrix. So I already told you, whenever you see a determinant, it's not a matrix, it's a determinant. So whenever you see a determinant, you have to push the sigma inside the determinant. You have to select either a row or a column. That is the first thing. Now, on what basis you are going to decide that which row and which column should we select? Okay. So that is column number 2. Can you see completely in terms of n? Column number 3 completely in terms of n. And your sigma, can you see is completely in terms of r. And your column 1 is completely in terms of r. That's why the sigma will get attached to column number 1 specifically. I hope that this is clear, Supriya. Option D, absolutely right. Yes, so that's how you do it. This is your determinant, sigma r, sigma 2 raised to power r, sigma 3 raised to power r. These column 2, column 3 as it is, copy paste. Sigma r is this, sigma 2 raised to power is this, sigma 3 raised to power is this. Clearly that you have to multiply 2 in this, 2 in this, 2 in this. So rows are proportional. So yes, rows, you can make the rows equal as well. So it will become 0, right? Now determinant property. Now some of you are wondering that, okay, the syllabus has been deleted, the syllabus has been reduced if I talk about the properties. But there are some questions which have been found in your 2024 April attempt. They are not using like a lot of properties, full-fledged properties, but a tinge of it. Okay, all right. Like a little bit properties are used. That's why we are going to do that. Okay. All right. Now, can you see that property, the value of determinants is not altered by adding or subtracting? Yes. So the moment we see any determinant which we have to solve and get the value of that determinant, but by looking at that determinant, we are not able to solve it. We are actually helpless because the numbers are very big. So now, can you see delta 1? So in here, which property can I apply? The property is this, that, okay, so over here, if I wish to change R1, so R1 can be changed with the help of R1 only. That's the only thing. R1 will be changed or replaced with the help of R1 plus you can consider any other row. So that will be alpha R2 and beta R3 as well. But R1 will be replaced by 1 R1. Can you see again column 1 will be replaced by column 1 plus now alpha C2 and something like that. Okay. So determinant value will not get changed. The determinant value will not get altered. I hope that this is clear. Let's understand with the help of this question. Yes. This type of question was there in your 2024 as well. We will solve that as well. So now can you see that a minus b 2b plus c is given as 1 and this is your f of x. And we are here to figure out that which of the value is correct. Okay. So over here we have to apply the property. The very easy property over here. So I want to create this a plus c minus 2b. A plus c. How will I get a plus c? Okay, first decide that, okay, I am going to apply that operation in row number 1. Right? And I want, so row number 1, row 1 plus or minus. Okay. So now I want a plus c because I want this to get created. So plus c. So row 1 plus row 3 will get me a plus c, right? So R1 plus R2. But what I want is R1. So a plus c I want, but minus 2b I want. So minus, this is row number 2. So minus, so this is row 3 minus twice R2. Sorry, this is R3. Okay, R1, R3, R2. So R1 plus R3, if I add R1 and R3, I will get A plus C, and minus twice of R2 will get me minus 2B. So that I can just make use of this expression. Shall we do that? Now your fx will become, tell me, R1 plus R3. So this is, so R1 will get changed. That means I'm gonna get a completely new row number 1. So x plus A, R1, then we are having R3, x plus C, minus twice of x plus B. Okay, again, so this is your R1. Now again, x plus 2 plus x plus 4. So this will be 2x plus 6. 2x plus 6 minus you will be having twice of x plus 3. And over here, this row. Okay, let me just now, rest of the elements will be same, x plus B, x plus C, and we are having x plus 3, x plus 4, right? We are having x plus 2, x plus 3, and we are having, we have to write, okay, so this is first, this is your second, third we have to write. Can you just tell me, x will get cancelled out, so it is A plus C minus 2B. That's what we wanted to have. This is exactly which I want to have, A plus C minus 2B, right? So can I write A plus C minus 2B over here? What about this? So 2x getting cancelled out. Okay, I'm getting a 0 in place of row number 2. What about the row number 3 now? Row number 3 we wish to calculate. So row number 3 would be okay. So x plus 1, x plus 3 will give me 2x plus 4 minus, we are going to get twice of x plus 2. So again, can you see this is going to be a 0? Determinant close. That's how I'm gonna get. And by the way, this I can replace this by 1. Now you just expand it. So fx will be equal to, now we just need to expand it right away. So 1 x plus 3 square, x plus 4, x plus 2. So that's it. X plus 3 square minus x plus 4, x plus 2. Okay, so this is nothing but x square will get cancelled out. Here we are getting, okay, so 6x and 6x again cancelled out. So 9 minus 8. So your answer, so fx will be 1. If you solve it, you are going to get 1. That means your fx is coming out as just 1. All right, you solve it, you are left with 1. Okay. So option B is absolutely right. Yes, yes, yes. Common value, true vision media, what's your doubt? The way we were taking common, the how many 2, how many 3, that's what you're saying it? True vision, is that what is your doubt? And Supriya is also having one doubt. Supriya, how did you write A plus C minus 2B? Okay, yes. Supriya, let me just clear your doubt. I applied this operation. Let me just show it to you. So I applied this operation over here, which is R1 goes to R1 plus R3 minus R2. Okay, I applied this operation, R1 goes to, you understand why did I do that? Do you understand this operation, that how this operation came to my mind? Because I know that I want to get A plus C. A plus C. So A is here in row number 1, C is here in row number 2. So I will have to add row 1 plus row 3. So can you see row 1 plus row 3? But wait. Now I want minus 2b. How will I get minus 2b? So this is your row number 2. So I have to subtract row number 2 with a 2, with a multiple of 2. So minus 2 R2. Okay. So this operation. Let's apply this operation now. R1 plus R3. So R1 is this. X plus A. R3 is this. X plus C minus twice of R2 is x plus b. Now Supriya, please tell me the final solution. X plus x minus 2x will be gone. A plus c minus 2b will be left out. Yes. And we just need to replace it with the 1. Okay. Yes, Supriya, we can assign any row, but this part should match. R1 goes to R1 plus whatever you want to do with the rows, obviously. And column 1 goes to column 1 plus or minus anything. Yes. Yes. So let me just write down what kind of row and column operations you can do. R1 goes to R1 minus R2 plus R3. You can do R2 goes to R2 minus 2R1 plus 3R3. Right? You can write R2 goes to R1 plus R2. Sorry, R2 goes to R2 plus R1. You can use any 2 rows as well. No, it's not mandatory to use all 3 rows. But if you are doing row operation, you have to just pick rows only. You can't do that. This is not allowed. R2 goes to R2 plus column 2. This is incorrect. What is incorrect? R2 goes to 2R2 plus R3. This is also incorrect. So what the point is, this 2 should not be here. R1 goes to R1. So with the help of the exact R1, you have to do that. Okay. I hope that this is clear. So column 2 goes to column 2 minus column 1 can be done, because column 2 goes to column 2. This part should be exact same, and then you can just use any other. Okay. So these are operations you can apply. Now, okay. So in your 2024, we have seen that NTA has asked problems from system of linear equation, whether it was homogeneous, whether it was non-homogeneous. So we will study that. Okay. We will study the system of linear equations now. So here you are having 3 equations. 3 equations. So A1x plus A2x plus A3x is equals to your let me just A, B, C, D, E, F, G, H, I. Can we do that? Okay. Let me write it over here. A1x plus A2x plus A3z. This is y. B1x plus B2y plus B3z. C1x plus C2y plus C3z is equals to D, E, F. Okay. So 3 equations are given to us and 3 unknowns are given to us. Yeah, R2 goes to R2 plus R1. Yes, Sanjay. So now system of linear equations, right? A1x, A2y, A3z is equals to D. B1x, B2y, B3z is equals to E. C1x, C2y, C3z is equals to F. 3 equations and 3 unknown are given to us. And now we need to check whether these 3 equations are having a unique solution or not. Unique solution means that the moment you solve all 3 equations, you are going to get one solution for x, y, and z. That is, it can be 2, 3, 5. The value of x, value of y, value of z. Okay. So it can be the solution can be unique, or it may be possible that you are getting absolutely no solution from these 3 equations. Right? No solution can also be a possibility, and infinite solutions can also be a possibility. So there are 3 kind of possibility if I talk about 3 equations and 3 unknowns. Did you understand this? 3 possibilities. Yes, wrong. Tanishka Pandey, wrong. Yes, so 3 equations, 3 possibilities should be are there. Okay, so now how do we rule out all the possibilities? What are the conditions for which it is having a unique solution, it is having a no solution, this equation is having a infinite many solution? Okay, for that, we need to understand 4 types of determinant. Let me just show you. First determinant is the determinant formed by all the coefficients of x, y and z. That will be a1, a2, a3. Okay, b1, b2, b3, c1, c2, c3. Okay. So the very first thing is we need to check this delta. We need to check this delta. Right? We need to check this delta. So let's check this delta now. If this delta is non-zero, that means we are going to have a unique solution. Okay. So the moment you find this delta and if it is coming non-zero, that means you are going to get a unique solution. That means you are going to get a value of x, y and z. Okay, so now the point is, if it is a unique solution, then you have to calculate that unique solution. You need to solve that unique solution which will satisfy all 3 equations. How will I do that? So unique solution, that means you want value of x, y and z. Right? You want value of x, y and z. So over here, value of x. So value of x will be given by del x by del. This will be del y by del. This will be del z by del. Yes, are you getting my point? Now you will tell me, okay ma'am, delta is known to us. And in this case, in unique case, unique solution, it is coming as non-zero as well. But what about this del x, del y and del z? What are you talking about? What is del x? Please explain this to us. How do we calculate del x? Okay. So let me just show you the del x. Okay. So del x will be nothing but, let me just show you right here. If you wish to create delta x, so your first row will be deleted. And your first row will be replaced by the constant def. This is your del x. Yes? Okay, def. Rest everything will be same. So now you know del x, you know del. Okay, del x, you know. What was del? What was del? Okay, let me just write del as well. So del will be this. A1, A2, A3. This will be your del. Okay, this will be your del. So del x, you know, you have to delete the first row and you have to put def in the place of first row. Now, but okay ma'am, we know del x. What is del y then? Okay, who is going to tell me? So for del y, you have to erase the second row, and in place of second row you have to write def, so that it will become del y. Yes? Getting my point? Okay ma'am, now we have understood del y as well. Okay, so you need to solve for all the determinants, all the 4 determinants. Now what about del z? Who is going to tell me? For del z, you have to replace the third column in the original delta, and you have to replace by def so that you get del z. Okay? Okay? Alright, so this is for your unique solution. So how do you get unique solution? Let's start with the beginning now. Suppose you are given with 3 equations, right? You are given with 3 equations. So first, the very first thing is you check for the original delta. Let me just write down the original delta. What was the original delta? So original delta is this. A1, A2, A3, B1, B2, B3. B1, B2, B3. Oops, not like this. Yes, so this is A1, A2, A3, B1, B2, B3, and C1, C2, C3. Yeah, x, y, z values, you are going to get del x. The ratio of these 2 determinants will give you x. Okay, we'll solve it. Okay. Alright, so this is your delta. If it is non-zero, then you are having a unique solution and you have to solve each and every for x, y and z. But what happens ma'am if it is become 0? This is more popular by the way. There are 99% chances that you are going to get this type of question. So please now listen to me carefully. Okay. So the moment you see three equations, you calculate delta, and if it is non-zero, then there are two possibilities. First possibility is infinite solution, and second possibility is no solution. Okay, when delta is zero, you can have two possibilities, either no solution or infinite solution. Okay, so for infinite solution, your rest three deltas should also be zero. If all four determinants are zero, that means definitely you are having infinite many solutions, right? Okay, and for delta equal to 0, at least one of the remaining three, del x, del y, del z, should be 0. At least one should be non-zero. If everything is 0, then infinite. If at least one is remaining, okay, all is 0 but del x is left, or del y is left, or del z is left, then we will say it is having no solution. Okay, all right, I hope that this is clear. Okay, one confusion, one doubt I am having, that how to know which row to delete for unique solution. So first of all, to figure out del x, you have to delete row number 1. Row number 1 if you delete, you will get what? Del x. Row number 2 if you delete, column 1, column 1 if you delete, del x. Column 2 if you delete, del y. Column 3 if you delete, del x. That's how you get. Okay. All right. Yes. Now we are having a homogeneous system, which is absolutely popular. Let me just show you. So this is a1x plus a2y plus a3z is equals to 0. Right? This is your homogeneous and this is your non-homogeneous. In non-homogeneous, you are having D, E, F. In homogeneous, you are having 0. A2, so it is b1x, b2y, b3z, and the third will be, okay, this is not visible, so this will be c1x plus c2y plus c3z is equals to 0. These are the three equations. Can you see the right hand side is absolutely 0, and we call it as a homogeneous system. Very, very important. So, and very, very easy as well, easier than the previous question. Okay, so okay, so homogeneous equation is having only two things. Homogeneous equations is only having two things. Either it is having unique solution, either it is having unique solution, right? So either it is having unique solution, or we can call it as a unique trivial solution. For del is equals to 0, non-zero. For unique trivial solution, del is not equal to 0. Okay, and for infinite solution, we are having del equal to 0. Please remember, in homogeneous equation, we are not having no solution. No solution is not at all a case. So can you see, homogeneous system is always consistent. That means either it will have unique solution or infinite solution. There is no concept of no solution in case of homogeneous. Okay, so it is very obvious that 0, 0, 0 will definitely satisfy these three equations, right? So we can't never ever say no solution to this homogeneous equation. It is common sense as well. That how can we say no solution? We can see that 0, 0, 0 is satisfying all three equations. How can we say that no solution is the answer of these three equations? Right? Is it clear? So yes, it has non-trivial solution if delta is 0. Trivial solution if delta is non-zero. So remember, Non-trivial means zero. It's opposite. Non-trivial means zero. Trivial means non-zero. It's the opposite. Okay. All right. So can you see non-trivial? So for non-trivial, remember delta is zero. That's it. Done, done, done. Shall we solve it? Delta 0. So can you see whether it is homogeneous? Acha. First of all, please tell me it is homogeneous or non-homogeneous. I'll wait for you guys. Homogeneous or non-homogeneous? Homogeneous or non-homogeneous? Who is going to tell me? Waiting, waiting, guys. Supriya is saying non-homogeneous. What about others? Okay, Hemlata is saying homogeneous. What about others? Quickly, why I'm not seeing the answers in the chat box? Homogeneous. It's homogeneous, Jeevan. It's homogeneous, Supriya. You need to understand that for non-homogeneous, we should have a constant. But can you see only x, y, z terms are there? And you know what? If I combine these two, take x common, 1 minus lambda minus 2y minus 2z is equals to 0. The second one will be x plus 2 minus lambda y plus z is equals to 0 minus x minus y minus lambda z is equals to 0. For non-trivial, delta is equal to 0. So it's very simple. 1 minus lambda minus 2 and then 1, 2 minus lambda and then 1 plus 1. We are having minus 1 minus lambda is equals to 0, and you just have to expand it, solve it, done, 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 done. Expand it, solve it, and yes. So 1 minus lambda shall we solve it? 1 minus lambda, and we are having minus of lambda 2 minus lambda. So we are having lambda minus 2 minus sign, we are having plus 1. Okay, then we are having plus 2 and we are having plus 2. We are having minus lambda plus 1. Minus lambda plus 1. Okay, and we are having minus 2 and this cross this. So minus 2. So we are having minus 1 plus this. So minus 1 plus 2 minus lambda is equals to 0. Let's solve it out. Yes, let's solve it out. So this is 1 minus lambda. This is lambda square minus 2 lambda plus 1. This is plus 2, 1 minus lambda. And this is, okay, so we are having minus 2. We are having 2 minus 1 is plus 1. So 1 minus lambda is equals to 0. Clearly, I can see 1 minus lambda, 1 minus lambda, 1 minus lambda can be taken out. And this is lambda square minus 2 lambda plus 1. This is plus 2. This is minus 2. So this is also gone. So we are left with 1 minus lambda. And this is lambda minus 1 ka square. So 1 minus lambda minus 1 ka square is equals to 0. That means lambda is 1. So yes, we are having a singleton set. Yes, Tanishka Pandey, I have adjusted the sign actually. I have adjusted the sign. So minus lambda was there. So I have written lambda minus 2. Clear? Easy peasy? Yes, yes, yes. है ना? So for the moment we see homogeneous, Mahesh is saying non-homogeneous now. No. One minus lambda over there. Where? I just expand this. You expand it your way, you will get that. So why 1 minus lambda over there? So I don't know what they are asking, what KKB007 is asking. Yeah, 1 minus lambda I have taken common. Cancelled out, but taken common. So we are left with this, right? All right, all right. So here we are having very good question. This is a very good question. Let's understand this. Okay, PQR is non-zero and the system of equations. Okay, so 3 equations are given. Again, non-trivial. The moment you see non-trivial, delta should be 0. Right? Non-trivial means delta 0. Trivial means delta not 0. It is the opposite way. Okay. So, no, delta 0. So, that's it. This is what? Tell me, homogeneous. Right? Because 0, 0, 0 is there. Homogeneous. So, just write it down. P plus A, B, C. A, Q plus B, C. Okay. A, B, R plus C. And determinant close, this will be equal to 0. Right? Now, understand this, realize this, and how to solve it. One way is right there, open it, expand it. But no, now we know the properties, we'll make use of it to simplify things, okay? So the very popular operation which almost works everywhere in some basic problems is that R1 we change. Okay, basically we change R2. R2 goes to R2 minus R1 and R3 goes to R3 minus R1. So we are changing R2 and R3. R2 changes to R2 minus R1. R3 also changes like that, R3 minus R1. So now your new determinant, the first row will remain same. We are not changing the very first row. Second row, you can think of multiple other operations as well. It is not fixed. Okay. Yes. So now A minus R2 minus R1. So this is R2. This is R1. A minus this. A minus P minus A. So it will become minus P. Q plus B minus B. It will become Q. C minus C. It will become 0. Right? Yes. Then A. This is your R3. A minus P minus A. So again it is becoming what? Minus P. B minus B. Okay, I'm going to get a 0 and this is going to be R and dun, we are done. Acha, you were teaching me Tamil now. Can you please tell me that what do we call maza aa gaya in Tamil or in Telugu as well? I mean, I had fun. We are having fun or matlab like that. Telugu or Tamil. That I am having fun. Vera level A. Everybody is teaching me different words. Single. Amazing. Amazing. What do we call amazing in Telugu or Tamil? Masu. Vera levelu. Okay. You decide till I solve the problem. So here we have this. Okay. And we just need to expand it. Let's just do that. So P plus A QR. P plus A, and we are having QR. Okay, minus B times we will have what? Minus PR, that's it. Plus PR it will be, and C times we are going to have this and this. So minus CPQ is equals to 0. Now understand, what do we need to figure out? So I can clearly see that I don't want a PR over here and a PQ over here as well. Okay, this is it. This, okay, so plus CPQ. I don't want a PR over here, I don't want a PQ over here. Okay. So what do? We divide the whole equation by PQR. Divide the whole equation by PQR. So now can you see QR and QR is gone, and we are left with P plus A upon P. So we are left with P plus A upon P plus. Can you see this will be QR and PR B by Q. So this is B by Q, and this will be PQ is gone, the C by R, and this will be equal to 0. So now can you see that B by Q is here, C by R is also here, P by P is 1, A by P is here, so P by P is 1, so this value will be minus 1, right? So this will be A by P plus B by Q plus C by R is equals to minus of P by P. This will give you minus 1, option A. Yes, yes, Supriya, you're absolutely right. Okay. Muck is G. Muck is Chi. Muck is Chi. Muck is Chi. Amazing ko Game Over Tamil is teaching. Yeah, I like this word. Arputham. Arputham. Yeah, right? Arputham is fine. I hope that you are teaching me correct words. Okay. I am trusting on you. Arputham. This was an Arputham question. Okay. This was absolutely Arputham question. Yes. Okay, so that's how we did this question. This is your delta. R2 goes to R2 minus R1, R3 goes to R3 minus R1, and the moment you expand, you will get this. Divide by PQR, you will get this answer. Okay. Okay. Arpudham. Okay. Arputhamana. Adbhutham in Telugu is, oh nice. This is a nice word. I love this word. Adbhutham. This was an Adbhutham question. Adbhutham question. All right, so this was a question from 2024. Now we are going to have some very good questions. 2024 JEE Mains. This is absolutely an Adbhutham question. Can you see? Now this is an homogeneous, this is a non-homogeneous, right? This is a non-homogeneous. Non-homogeneous. So for a non-homogeneous, they are talking about infinitely many solutions. That means all delta, del x, del y, del z is 0. Del x, del y, del z is 0. Okay, Supriya, yes, I have read your question. Okay, so I'll clear this after this question. Okay, that row y by 2 rows are proportional, then y determinant is 0. I will clear that doubt. But let's focus on this first. System of linear equations is given to us, so your del. So can I just write all 4 or all any of the 3 determinants? Let's start writing del. So 1 minus 2 and 1. Then 2 alpha 3. And then I have 3 minus 1 beta. Then I have del x. Del x. Okay, but what? So this is 0. But I don't want to open this. The moment I see this, can you see that alpha is also missing, beta is also missing. So it will give me an equation in alpha and beta, which will actually like two equations, two unknowns in an equation. So I will keep this inside. Let's talk about another, del x. Let's talk about del x. For del x, I have to write -4, 5 and 3 in the first column. So -4, 5 and 3 is replaced, and now can you see -2 alpha -1. Again, del x is also not giving me. Can you see in del x as well? I am going to get two unknowns. So no, it's a big no. Del x I don't want to calculate. I want to go for del y and del z. Yes. So del y will give me, so 1, 2, 3 and 1, 3 beta is same. And the second column will be replaced. So -4, 5 and 3. -4, 5 and 3. Did you understand how smartly I am doing this problem? Did you understand this? That del if you calculate, you are going to get stuck. Del x you are going to calculate, you are going to get stuck. Right? But del y may you are definitely going to get beta now. And what about if you expand del z? If you expand del z, so del z is what? So the column number 3 will be replaced now. So 1, 2, 3, -2 alpha -1, and this is your del z. So this is -4, and this is 5, and this is 3, this is 0. This will give you alpha, this will give you beta. So you don't need alpha. You don't need delta as well. This can be deleted. Now let's start doing this. Okay. So 1, 5 beta -9. 5 beta -9. Then we have +4, 2 beta -9. +4, 2 beta -9. And then we have 1. So 3 to the 6 -15. 3 to the 6 -15 would be 9. But with a minus sign is equals to 0. So 4 to the 8. 8 to the 13 beta. 9 so is equals to 27. Is it correct? No. So 9 and 9, 18, and then you are having 4 9s are 36. 36 plus 18 will give you 54. 4 to the 8 plus 5. 54. Yes. So this is 54. So this is your beta. 54 by 13. Okay. So this value will be 54. Right? Now you just need to calculate the value of alpha. Okay. You just have to calculate the value of alpha. What is 12 alpha? So from here I'm gonna get, so 3 alpha plus 5. 3 alpha plus 5. Then we have plus 2, and with 3 to the 6 minus 15. 6 minus 15 is -9. And -4 times you are going to have -2 minus 3 alpha. So -2 minus 3 alpha is equals to 0. So 3 alpha, and we are having 4 3s are 12. 12, so 15 alpha. Then we have 5 minus 18, and 5 plus 8, 13. 13 minus 18 is -5. So equals to 5. Yes, alpha is coming out as 1 by 3. So yes, alpha is 1 by 3. So 12 times 1 by 3 plus this. So 4 plus 54. So 58 is the correct answer. Yes? Okay. Yes, Ashwarya, absolutely right. Beta, absolutely right. Easy one. Most of you people are saying this is an easy question, but you know what? There are a very few people who have solved this question. Why? Because in the very beginning, they started doing delta and delta x. The moment you pick delta and delta x, it will waste your time in the examination. And in the exam temperament, you will lose that confidence. You will leave that question. Okay. So it is actually an easy question if your mind is balanced. Okay, so let's not pick delta. I have 4 options. Picking the right. Okay, I need only two unknowns are there. So I need only 2 determinants to solve. 2 equations are there. That's it. So to write delta, we need to pick, and most of the students picked delta and delta x, and they started jumbling between those determinants, right? Okay, so yes. That's how it is. All right. So this is okay. Let me give you a homework question. The system of linear equations is given to us, again non-homogeneous, and they are saying it is having more than 2 solutions. Okay, so more than 2 solution means what? They are having infinite solutions only. More than 2 solution क्या होता है? Either it has a unique solution, that is single solution, or it has no solution, that means not at all a solution, or it has infinite solution. More than 2 solution means definitely it is having infinite solutions. Right? All right. Now let's understand this very important topic, which is symmetric and skew symmetric matrix, right? What is a symmetric matrix? So basically, a symmetric matrix is that matrix wherein if you take transpose of that matrix, now suppose this is a matrix, and if you take transpose of this matrix, you know how to take transpose? By interchanging row and column. So 2, 1, 3 will now become your column 1. 1, 0, minus 2 will become 1, 0, minus 2. 3 minus 2, 5 will become 3 minus 2, 5. Right? So this is A transpose. A transpose. Both, can you see, absolutely equal? These two are absolutely equal. That means it is symmetric matrix. This is symmetric matrix. Okay. So why it is happening? Have you given a thought that why these two are looking exactly same? What is that quality? What is that property? What is that feature which is making A and A transpose absolutely equal? Have you thought about it? So the properties, if you carefully observe such type of determinants or matrix, that is symmetric matrix, can you see that A12, this is A21. A12, A21. This is A13, A31. This is A32, A23. Right? Yes, A3. So now I can see that, okay, the conjugate elements are equal. What are the conjugate elements? Aij will be equal to Aji. There is no restriction on diagonal element, but the conjugate elements are matching. That's why it is called as a symmetric matrix. Now, what about skew symmetric matrix? So, skewed symmetric matrix is such that if it is A, and if you wish to calculate A transpose, it will become minus of A. Right? So, if I calculate A transpose out of this, so 0 to 4 now will become 0 to 4. Minus 2, 0, minus 3. Minus 4, 3, 0. Now, can you see that over here it was 2, it has become minus 2. 4 has become minus 4. This was minus 2, it has become 2. Minus 3 plus 3. Minus 4 plus 4. 3 minus 3. Okay, alright. That means each and every element now has become the negative or the opposite sign. It is becoming of the opposite sign. So what is that property in that element? So I can clearly see that all the diagonal elements should be equal. That is the first thing. The diagonal elements should be equal to 0. The diagonal elements should be equal to 0. That's the first and foremost thing. And the conjugate element this time are equal but opposite in sign. So Aij is equals to minus Aji. Okay. So the moment I wish to create a symmetric matrix, how will I do that? If it is a symmetric matrix, so I will write A, B, C, anything in place of diagonal. I'm talking about symmetric, okay? A, B, C. Now, if it is D, it will also be D. If it is E, it is also E, F, F. These are the conjugate elements, hence they are equal. This is for symmetric. Now, what about skew symmetric? If somebody is asking me to form a skew symmetric matrix, how will I form it? So, okay, 0, 0, 0. First of all, in skew symmetric matrix, all diagonal are 0. If it is A, it will become minus A, B, then minus B, C, then minus C. Hence, we are done. This is a symmetric matrix. Okay? Yes? Alright, so now we know that what is a symmetric matrix. What is a skew symmetric matrix? Now, very important property. So any matrix can be written as sum of a symmetric and a skew symmetric matrix. Any matrix can be written as sum of symmetric and skew symmetric. This is your symmetric part. This is your skew symmetric part. Okay. Symmetric part, your P is nothing but half A plus A transpose. Skew symmetric part is nothing but half A minus A transpose. Okay. So any matrix can be written down as sum of symmetric and skew symmetric. Here P will represent symmetric. How will you form P? P is nothing but half A plus A transpose and Q is nothing but half A minus A transpose. This is your symmetric matrix. This is your skew symmetric matrix, by the way. And you know what? The moment you add these two, try adding P plus Q. So you will realize, okay, A transpose is getting cancelled out. Half A plus half A will become A. Left hand side, right hand side equal, hence proved. And this is your symmetric. This is your skew symmetric. Right? Yes. Shrinu knows it. Shrinu.k knows this property. Okay. Yes, for skew symmetric, Sumati, diagonal elements are always 0. All right. So we have a question from JEE Mains 2021, and this topic recurrently they pick. Symmetric, skew symmetric topic recurrently they pick. Okay, in your JEE Mains. This is your matrix, and yes, A matrix can be written down as P plus Q, where P is symmetric, Q is skew symmetric. Okay, so now I can form P and Q both. Matlab, I know in and out of P and Q. That is the first thing. Now they are giving determinant Q is 9. Then the sum of all possible values of determinant P. What would be P? Who is going to tell me? Half A plus A transpose. Right? What is A? Who is going to tell me? A is 2, 3, A 0. What is A transpose? So 2, 3 will be vertical, A 0. And half, adding these two will give me 2 plus 2, 4, 3 plus A, this will become 3 plus A, and this is A plus 3, and this will become 0. So we are going to get 2, 3 plus A by 2, A plus 3 by 2, and this is 0. This is your P. This is your P. We can calculate determinant of P as well. Determinant of P will be, who is going to tell me? This minus this. So 2 minus multiplication of this. So minus A plus 3. Okay. So 2 2s are 4. So 1 by 4 A plus 3 square. This is your determinant P. This is 0. Yes. Determinant P is this. Clear? Now Q. So Q will be half A minus A transpose, right? So Q will be equal to half A minus A transpose. Can you see 2 minus 2, 0? 0 is, this is also 0. Now this is A minus 3, this is 3 minus A. A minus 3, 3 minus A. So determinant of Q will be 0, right? This 2 will go inside over here. So 0 minus, you are going to have this into this. So 1 by 4, A minus 3, 3 minus A. Okay. Or you can simply write determinant q is equals to minus sign if you can take common. So a minus 3 whole square by 4. Determinant q is given as 9. A minus 3 whole square by 4. So determinant q is given as 9. Okay. So that means a minus 3 whole square by 4 is given as 9. 9 fours are 36. So a minus 3 either is 36 or minus 36. So the value of a will be 39 or it will be minus 33. So value of a will be either 30. Okay, oops. Sorry. I forgot to take the square root. 6 or minus 6, right? 6 or minus 6. So either 6 or minus 6. So it will become 9 or it will become minus 3. So a is 9 or minus 3. So you can just plug in the value over here. The moment you put 9, 9 plus 3, 12, 12 ka square, 144 by 4 is the first answer. The moment you put minus 3, it will become 0. Okay. So 4. 4 3s are 12 and 4 6 are 36 and 0. So 36, sum of all possible values of determinant P. So that will be 36 plus 0. Yes, Chandrakala, thank you. A is, no, Chandrakala, you are doing the same mistake. Square roots, 9 fours are 36. Square root of 36 is what? 6. Because it is a square, it can be minus 6. Yes, Aishwarya. Done. Nice question. This is actually Adbhutam. This is Adbhutam question. I like this question a lot. That's why I picked that question from 2021. Why are you not taking the other solution? What other solution? I am taking both the solution. The moment I put 6, I get, the moment so a is what? 6 plus 3, 9. Or a is minus 3. So 9, the moment I put 9, I get 9 plus 3, 12 ka square, 140. The moment I put minus 3, I will get 0, na Supriya? Okay. Now adjoint. Let's talk about the adjoint. So now we know minors. By now we know minors. By now we know cofactors. So we can know that what is a cofactor matrix. Okay. So suppose you are given with this matrix, which is A matrix. Can you find the cofactor matrix? Definitely. So cofactor of this element will be C11, then C12, C13, C21, C22, C23. Okay, C31, C32, C33. You know this, right? Okay, now take transpose of it. The moment you take transpose of this cofactor matrix, what do you get? Tell me. So C11, C12. So C11, C12, C13, C21, C22, C23, C31, C32, C33. This is transpose of your cofactor matrix. And you know what? Transpose of your cofactor matrix is nothing but your adjoint of that matrix. Yes. How to calculate adjoint of any matrix? Calculate cofactor matrix and then take transpose to get adjoint of that matrix. Okay. So transpose of cofactor matrix will give you adjoint of that matrix. I hope adjoint is clear. Transpose of matrix of cofactors of elements of matrix A. Inverse of a matrix. Now let's understand some points related to inverse of a matrix. So first of all, for each and every matrix, inverse does not exist. There are a few matrices for which inverse exists. What are those matrices? Those matrices whose determinant is non-zero. We call it as a non-singular matrix. Yes, non-singular matrix means this is N. Non-singular matrix, that means determinant not equal to 0. The moment you see determinant not equal to 0, that means That means that its inverse exists, or you can call it as an invertible matrix. That is first thing. So whenever you wish to calculate inverse, the very first thing you're going to check is whether determinant A exists or not. I mean, if it is 0 or not. If it is non-zero, then only you can call it as, okay, adjoint of A upon determinant A will give me this. Okay. All right. Adjoint A. Yes, absolutely. Adjoint A upon determinant A will give you A inverse. All right. Yes. So there is actually a very important property, the basic property of all the properties. This is the master property. Master teacher, master property. So master property says that A times adjoint of A, or adjoint of A times A. Both are same, and it is nothing but determinant A multiply identity matrix. This is the master property, and from this property we will derive all the properties. But we are not here for the derivation. Let's go straight to the properties of adjoint. Very important properties. I'll list all the important properties. First property, very important. Adjoint of A is nothing but determinant of A n minus 1. How many of you know this property? Please let me know honestly. Because 100% chances are there that 4-mark question will be there from this property. This property will be used. Okay, there will be some other properties as well, but it will be useful in that question. Supriya, that means determinant value. The moment you solve it, you finally get that value. You expand that determinant, it should be non-zero. Non-zero. Okay. All right, I guess so many people are saying yes, but when we solve problems, you say, okay, ma'am, we don't know this property, okay? So, adjoint of A, the determinant value will be determinant A raised to power n minus 1. What is n? N is nothing but the order of that matrix, right? Okay. Now, adjoint of okay. Let's focus, after first property, let's focus on the third property, wherein can you see 2 times adjoint is written? Adjoint of A is determinant A raised to power n minus 1. Twice of adjoint A is written. Adjoint of adjoint A. So that will be determinant A raised to power n minus 1. Now can I tell you the extension of it? Adjoint of A. If it is written 3 times, determinant A raised to power n minus 1 cube. Okay, now you know. If it is written 4 times, n minus 1 raised to power 4. If it is written k times, the value will be determinant A raised to power n minus 1 raised to power k. Okay. All right. So this property is sorted. All right. Okay. Now this is the second property, adjoint of A. Adjoint of A is determinant A raised to power n minus 2 into A. This is less likely to be there in your JEE Main, upcoming JEE Main. I told you 1, 3 and this. These properties are, this property is also important. Whenever you see like some things like adjoint of 2A, so you can use this property. This 2 will come out, but with a power of n minus 1, that is order minus 1. This is again very important property, right? And this is again reversal law property. Adjoint AB is adjoint B, adjoint A, reversal law wali property. And again this is, so the moment you have to find adjoint of A square, what will you do is adjoint of A whole square, right? You can do that. Yes, second property, it's true, yes. All right, now let's start with some questions. Okay, so class ka time, yes, we will solve. Now we have to solve problems, just 1 or 2 topics in between, and half an hour more. We started at 7. I promised that 2.5 hours we'll take, so almost 2.5 hours we are going to finish. 7 to 9:30, 2.5 hours. Okay, all right. Yes, if the matrix A is this, B is this, C is this, okay, so we need to figure out this. All right, C is equals to 3A. All we know is matrix A. All we know is matrix A. Okay. So what we will do is we will put the value of, okay, so this is determinant of adjoint of. Now B will be replaced by adjoint of A. C will be replaced by 3. Okay, one more property. Okay, one more property I want to tell you that, okay, shall I write it over here? If you have this determinant K, I have told you multiple times. So this K will come out, but the power will be order of that matrix. Okay, so if you have 2A, so this will become 2 square determinant A. Very important property, very, right? Very important. These two properties are absolutely important. Okay, so now we are having this. This is your question that adjoint of B is replaced by adjoint of A. So this is your B. Okay, and C is replaced by 3A. Correct? Now let's apply the property. So we know that adjoint is written twice. So this will become determinant A raised to power n minus 1. Order is 3. So n minus 1 square, because twice is written upon. Now the 3 will come out and the power will be n determinant A. Let's put the value of n will be 3. 3 minus 1. So it will be 2 square. So 2 square upon 3 ka cube, and we have determinant A. So we are having 1 upon 27 and determinant A ka cube. All we need to do is calculate the value of determinant A. Can you tell me the value of determinant A? Who is going to tell me? So now 1. 3 3s are 9 plus 4. 9 plus 4 is 13. Then we have minus 1. 3 minus 4 is again, so plus 1. And okay, I am not able to see it. Minus 1 minus 3 will become minus 4. So it is minus 8. So can you see 14 minus 8 is what? 6? Is it so? Right? So yes, 6 into 6 into 6 upon 27 is 3 into 3 into 3. So this will become 2 cube, that is 8. Is it correct? Yes. So many of you are saying 16. Nahi, one Nidhi Verma, why are you saying 16? Okay, future doctor is saying, can you speak Tamil, ma'am? Yes, I can speak Tamil. Vanakkam, future doctors. And yeah, so Enna Pandra. And let's go back to Atutha question. Okay, yes, future doctors. How is it? Determinant A cube. Yes. Okay. So now can you see this is determinant A square ka square. This is 4 and this is 1. Determinant A raised to power 4 upon determinant A is A cube, right? Getting it? This is determinant A, this is determinant A, n minus 1 square. So n is 3. 3 minus 1, 2 square, 4. I miss square upon square. Okay. You didn't notice the 2. Okay. The new visitors on this channel, na? The new visitors on this channel will ask me that, okay, ma'am, can you speak Tamil? They don't even know that from where I am able to speak Tamil, right? Yeah, na? It's our secret, by the way. Okay. All right. Now we have another question. Now I am not going to help you. Quickly, you are going to tell me. And by the way, the last question was Adbhutam question. Telugu also I speak. Adbhutam. Who is going to tell me the answer? 1, 2, 3. 3 times determinant is adjoint is written. So now we know that how to solve it. So this will be determinant A raised to power n minus 1. Okay. And cube. This will be adjoint of A. Okay. N is what? Order 3. So 2 ka cube. So determinant A 2 ka cube. Remember, this is 2 cube. This is not 2 multiply 3. So this is determinant A raised to power 8. 2 raised to power 8. 2 raised to power 8. 2 raised to power 8 is 256. Right? Clear? I forgot Arpudam. Arpudam is also Adbhut. Arpudam is good. Yeah, I am having fun. Arpudam is what? Okay, so 256 is the right answer. Let's go back to the Adbhuta question. All right. Who is going to tell me the answer of this question? Now, this is actually a very good question. Actually, Adbhutam, which will test the conceptual thing. Okay. By the way, this is determinant A and this is not determinant. This is not at all a determinant. Adbhutam question. Yeah, Adbhutam. Yes, Aishwarya. So this is determinant A and this is adjoint of A inverse. Okay, so determinant A, adjoint of A inverse. All right, so we know that the basic definition of adjoint of A. Adjoint of A, who is going to tell me? Adjoint of A. So adjoint of A is nothing but A inverse into determinant A, right? This is from the definition of A inverse. From the formula, A inverse formula, everybody knows. So adjoint A is nothing but A inverse determinant A. But we are not interested in adjoint A over here. Are we? Not at all. We are interested in adjoint A inverse. So in this equation, can I replace A by A inverse and rewrite this? Definitely. So adjoint of A inverse will be equal to now A inverse again inverse. And this is determinant of A inverse. So this is A inverse will become A and this will become 1 upon determinant A. 1 upon determinant A. You know this? Determinant A inverse. One more property. Determinant of A inverse is nothing but 1 upon determinant A. Right? So this is A inverse ka inverse, A upon determinant A. Adjoint of A inverse. So this is same. Now this is nothing but A upon determinant A. So this is actually coming as matrix A. Now can you see option B is having matrix A? Yes. All right. So that's how we do it. That's how we do it. Very good question. Hai na? Conceptual clarity we are getting from this question. How to approach any question. Okay. All right. And on this question, if you have not liked the session, please do like it. And now I'm gonna take a doubt from a student, Supriya, who is asking a doubt from since very long. So she is saying Supriya's doubts. Supriya ka doubt lete. Supriya's basic doubt. She is asking basic doubt. That she is saying whenever in a determinant 1, 2, 3, let's say, and this is 4, 8, 12. And this is 2, 7, 9, something else. Okay. So this is 0. I am saying that the determinant in which rows or columns are proportional, any two rows or any two columns are proportional, na? So yes, what do we do in such questions? Why it is becoming 0? So we need to prove that why it is becoming 0. Can you clearly see that row 2 is proportional to row 1? If I multiply 4 in this, I'm gonna get this. Multiply 4 in this, I'm gonna get this. Multiply 4 in this, I'm gonna get this. Yes. Okay. Right. Clear? Now, can I take 4 common? Can I take 4 common from row number 2? If I take 4 common from row number 2, what do I get? Again, 1, 2, 3, 2, 7, 9. Okay. Now, what you can do is you can simply expand this to know that this is 0 or not. If two rows are identical, if two columns are identical, then also the determinant is 0. It's the same thing. If two rows are either identical or proportional, the determinant is going to be 0. Now we need to prove whether this is 0 or not. So you can just simply expand this, or what you can do is you can apply operation row 1 goes to row 1 minus row 2. So if you apply this operation, now the new row 1 will be 1 minus 1, 0, 2 minus 2, 0, 0. So if any row becomes 0, and if you expand it, it is going to be 0. This is also one of the property. If any of the row or column of any determinant becomes 0, the overall determinant becomes 0. Is that clear, Supriya? Please give me a green signal. Yes, ma'am, understood. And you can go ahead so that, yes, your doubt is clear now. All right. So we have a next question in front of our screen. And the question says, let A and B be two square matrices of order 3, such that determinant A is given as 3, and this humongous expression, I can see, giant looking expression, we need to figure out the value of this expression. Okay. So determinant of A inverse, adjoint of B inverse, adjoint of 2A inverse. One by one we have to apply the property. Okay. So first of all, I can see 3 different determinants are there, or matrices are there. So we can separate them out. First step is separate each and every. So determinant A inverse, adjoint of B inverse determinant, and then adjoint of 2A inverse. Okay. So this is, I guess, this is sorted now. Determinant of A inverse will be 1 upon determinant A. What about this? Adjoint B inverse determinant. So for that, let's understand, let's recall some properties. So we know that adjoint of A determinant will be determinant A raised to power n minus 1. Right? Let's apply property in both the determinants. First is this, second is this. Adjoint B inverse. So now we are having determinant A raised to power n minus 1. So it will be determinant B inverse raised to power n minus 1. What is n? Order 3. So n minus 1 will give me a square. And over here, determinant 2A inverse square will be there. Okay. Determinant, this is also sorted. Determinant B inverse square will be 1 upon determinant B. So 1 upon determinant A and 1 upon determinant B square, and this we need to stop over here. Let me remind one more property. Determinant Ka will be equals to K raised to power n determinant A. So this 2 will come out. But this 2 will have power 3 because order is 3. 2 cube. But there is also a square. Please don't forget this square. So this 2 will definitely come out. 2 cube but with a square, and this is determinant A inverse square, right? And this will come, determinant A inverse square will come down in the denominator. So now we are having 2 raised to power 6, and we are having determinant A cube, determinant B square. Determinant A cube, determinant B square. So now let's plug in the values. determinant A cube, okay, 3 ka cube, and we are having determinant B square, so that means 2 ka square. Okay, so 2 raised to power 4 upon 3 cube. So 2 raised to power 4 upon 3 cube will be 16 by 27. If done nicely, step by step, you will get the correct answer, okay? One by one step at a time, one property at a time. Yes, game over, Tamil. This is actually Adbhutam. Adbhutam question. Acha, by the way, let me just, I have a curiosity that some of you speak Tamil, some of you speak Telugu, right? Some of you speak Tamil, some of you speak Telugu. Isn't it the case? Isn't it the case? Are like people who speak Tamil can also speak Telugu. Do you understand Tamil? Like Telugu speaking people understand Tamil a little bit or not at all? Or everybody knows both the language, Tamil and Telugu as well? Aishwarya is saying Telugu only. Okay. Some of you are into Tamil, some of you are into Telugu. Okay. So I need to learn both the languages then. Tamil and Telugu both. Chalo. Okay, so we have a question from JEE Mains 2021. Very good. Again, these questions, actually these are my favorite type of questions. I have kept in the very end these type of questions, right? So yes, a 3x3 matrix is given to us. We need to calculate this. So yes, so what we can do is, I can clear, now I know. Now we have, yeah, I know Tamil, Telugu are different. But I was having that idea, okay, because some people are very good at Telugu, but they might know a little bit of Tamil. And those who are good at Tamil, they might know a little bit of Telugu, like that. Exactly. Sumati says that, okay, we understand that what they are trying to convey, but we can't speak fluently. Yes, that's what I was trying to know. Now, these type of question, now you understand, na? You solve it and you get something related to determinant A. In the last, what we do, let me just show you. In the very last, what we do is we put the value of determinant A, and now we put the value of the final determinant. In the very end, we put the value of the determinant. In such way, can you see, last may we need, in the last, we need the value of determinant A. So first thing is, what we need to do is, we need to calculate the A matrix and calculate determinant A. So we can do that. Or what we can do is, we can pick that first, solve it nicely, and then calculate the determinant A. Okay. Alright. So determinant 3 adjoint of 2A inverse. Okay. Alright. So now this 3 can come out. Can I write the properties? Determinant Ka is equals to can you see this property? I have used it in almost each and every question. This constant will come out but with a power. So 3 order is what? So 3 cube. Determinant of adjoint of 2A inverse. Determinant close. Now another property, adjoint of A is nothing but determinant A raised to power n minus 1. Okay. 3 cube. 2A inverse. Now can you see power will be n minus 1, 3 minus 1, 2. So this is 27 multiply. Now again this property, can you see the very first property one more time? This K will come out with power n, this 2 will come out with power 3, but square is also there, 2 cube square, and we have determinant A inverse square. So now we are having 27, we are having 8 ka square 64 upon we are having determinant A square. So this determinant A square will be in the denominator. Let me just write it over here so that you all can see. Yes, so this is upon determinant A square. So for that we need determinant A. So let's write down the value of A first. So A will be, who is going to tell me all the values? If I is equals to J, that means all the diagonal elements are 2. All the diagonal elements are clearly 2. And if I is less than J, okay. So I less than J, that means A12, A13. 1, 2, 1, 3. So for that I'm going to use this. So for 1, 2, so this is 2 minus 1, so minus 1. And for 1, 3, we are going to have 3 minus 1, so this is 1. This is 2, 1. So again minus 1. And this is what? 2, 3. So 2, 3. So 2, 3. 3 minus 2. So this is minus 1. This is again minus 1. This is 1. Right? This is how your plus 1, 1, minus 1, 2. Yeah. This is 8. Minus 1. Now it's fine. Determinant A, if you calculate it, so I'm just copying it right now. Determinant A value is 4. Yes, determinant A value, if you calculate, it will be 4. So just plug in the value over here. Okay, so you'll get the answer 27 into 64 upon 4 ka square. So this is 27 into 4 will be your answer. 7 4s are 28. 4 2s are 8, 9, 10. 108 will be the correct answer. Right? Yes. Clear? Atuta question now. Okay, this is from JEE Main 2024. JEE Main 2024. Right? Yes. So this is your fx and we need to figure out 2f of 0. Okay, all right. So before actually this question, so Mansi is saying ambulance number, nice, good one. Nice observation. Okay, so yes, now we will talk about, one student was asking that in chat box as well, that he had given the question paper on 31st January and he saw this question from the differentiation of determinants and he left it right there. But differentiation of determinant is absolutely easy. Let me just talk about it. So delta x, so we are given with a determinant. This is f1x, f2x, f3x. Then we have g1x, g2x, g3x. Then we have h1x, h2x, h3x. Okay. F1, F2, F3, G1, G2, G3, H1, H2, H3. This determinant. Now we need to figure out del dash x. How do we do that? So you have to think. You can differentiate the determinant in 2 ways. First, not in 6 ways, 2 ways. Either row wise or column wise. Okay. Let's start with the row wise. Okay. So in what we do row wise is, we will write this del dash, the derivative, in terms of sum of 3 different determinants. The very first determinant will have the row 2 and row 3 absolutely same. This is row 2, this is row 3, absolutely same. But the first row will be differentiated f dash x, f2 dash x, f3 dash x. Okay. In the second determinant, I'll be differentiating the second row, G1 dash X, G2 dash X, G3 dash X. In the third determinant, I'll be differentiating H1 dash X, H2 dash X, H3 dash X. Okay. So row 1 is differentiated, row 2 is differentiated, row 3 is differentiated, like that. And rest, row 1 and row 3 will be same over here. Row 1 and row 2 will be same over here. Here row 2 and row 3 will be same. Okay. If you wish to differentiate column wise, then what will you do? So in the very first determinant, you differentiate the first column. Column 2, 3 remains same. Second may you differentiate the second column, and column 1, column 3 will be same. And over here you differentiate column number 3, 1 and 2 will be same. I hope that this is clear. Now we will solve JEE Main 2024 question. Let's do that. Okay. So first of all, we have to calculate f of 0. Actually twice of f of 0. So twice of f of 0. So f of 0, so it's very easy. You put 0 over here everywhere. So it will be 0, it will be 1, it will be 1. Then we have 2, then we have 0, 6, 0, 4, minus 2. Yes, Supriya, absolutely. That's the whole point. And both should be exactly same, right? The final answer, the final solution would be same. All three determinants will not be same. The final answer, the moment you solve it and calculate del x, the final derivative will be same. Okay, so this is what your f of 0. Plus, now you want to calculate f dash 0. Okay, so now please understand, we are doing in one step. Okay, in shortcut we are doing. Not shortcut, but I will call it as a mental mathematics we will do. Are we ready for mental mathematics? Right? In one step we have to do it. F dash 0. Let's do it row wise. Okay. So first of all, understand that after differentiating, we have to put 0. Okay. So over here, I'll be keeping row 2 and row 3 same, and I'll be differentiating row 1. Okay. Plus, over here, I'll be differentiating row 2. But row 1, row 3 will be exactly same. Plus, over here, I'll be differentiating row 3 and row 2, row 1 will be same. Okay. Alright. Yes. Ready? Are we ready? Yes. In one go, we will do it. You will see. Differentiating row 1 dash. So, differentiate this. 3x square. And put 0. Then and there. 3x square. So, 0. You will get a 0. Right? 3x square and put 0. You will get 0. What about this? 4x. The moment you put 0, 0. Right? Differentiate this. So 0 plus 3. No need to put x is equals to 0 because the derivative is 3. So we have written 3. Is that clear? Now row 2 and row 3 will be exactly same, but we have to put 0. So that will be 2, 0, 6. Then we have 0, 4, minus 2. Yes. What about this? Row 1, row 2 dash, row 3. So now row 1 will be exactly same. So put right away. 0, then you have 1, then you have 1. So we are putting 0, 0, that's it. Now we are differentiating row number 2. So that will be 3 2s are 6x. And plus 0, so 6x plus 0 will give me a 0 when I put 0. We have 2 over here, we have 3x square, so it will give me 0. And then we have, okay, so now directly we are going to put 0 and then 4 and then minus 2. Last, over here we'll only differentiate R3. So 3x square minus 1, the moment I put 0, I'll get minus 1. 4 differentiation will be 0, 2x square. 0, and row 1, row 2 will exactly be same, but we need to put 0. So 0, then we have 1, then we have 1, and row number 2 will be 2, 0, and 6. Done. Now we just need to expand. So this is your f dash 0. This is your f dash 0. Shall we start? So can you see this is absolutely 0. This is absolutely gone. Only these two determinants are left out. So let's just solve this first. So twice of. So minus 1, we have minus 4. So we have 4. And then 1, we have 4 to the 8. Then what about this? So we are having 3, 4 to the 8. 8 3 is 24. So we are having 24. So this is first thing. Now f dash 0 and then plus. Let's solve this. Okay. So let's solve along this. So 6, that's it, with a negative sign. So minus 6. So we are having 8 plus 4, 12, 24 we are having, plus we are having 24 minus 6. So 24 plus 18 is the final answer. 24 plus 18 will be 42. Yes. So 42 is the final answer of this question from 2024. Correct? All right. Now I have actually a shortcut technique to tell you all. So over here, the moment you see especially for 2 cross 2 matrix, the moment you see 2 cross 2 matrix, and you might have seen such question wherein this order 2 polynomial is involved. This is matrix polynomial is involved, okay? So by looking at this matrix, we can form this polynomial equation. Let me show you the shortcut over here. So yes. So first of all, this we can frame this polynomial right away. How? So a polynomial which satisfies polynomial, matrix polynomial satisfies matrix is equals to a square minus trace of a times a plus we have determinant of ai is equals to 0. So you can directly form this matrix polynomial. What you need to know is trace of a. What is trace? So trace of a I can clearly see is nothing but 3 plus 2, that is 5. So can you see a square minus 5a plus, now determinant a, who is going to tell me? So determinant a will be 3 2 is 6 minus 5 4 is 20. So it is minus 14. So it will become minus 14 times I is equals to 0. That's how you can form any matrix polynomial. Right? Very important. This is a shortcut. Otherwise, what you can do is, there is a bigger, like proper method to get this polynomial equation, but it is absolutely an easy shortcut, which will help you in your JEE Main 2024, because this topic, this matrix polynomial, NTA is asking since past few years. Okay. All right. Can I tell you the another method? The overall, okay, give me just 2-3 minutes. I want to tell you the another method, okay? So 3 2 minus 5 minus 4, okay? 3 2 . minus 5 minus. Otherwise, what's the overall technique to obtain this? Let's understand this. So you have that Cayley-Hamilton method. Cayley-Hamilton method, right? So to form that matrix polynomial, this is your step number 1. You have to first of all figure out A minus lambda I. A minus lambda I. So A is what? Tell me. 3, 2, minus 4, minus 5, minus 4. Right? Cayley-Hamilton. Okay. So A minus lambda times I. So lambda times I. So now can you obtain this A minus lambda I? Matrix I am talking about. So 3 minus, so this lambda will go inside, lambda. So 3 minus lambda, it is very easy. Then 2 minus lambda. This is absolutely similar. Okay. Now take determinant out of it. Take determinant and make it 0. This is your first step. Take determinant. So the moment you take determinant, what will you get? Tell me. 3 minus lambda, 2 minus lambda. And you have minus 20 is equals to 0. The moment you solve it, you will get lambda square. Then you are having, okay, minus 5 lambda. Then you are having 6 plus 14 is equals to 0. Right? You are going to have this. Plus 14, sorry, minus 14 is equals to 0. So you are going to have minus 14. So yes. And then second step, replace lambda by A and replace constant by ki. So this is lambda, so A square minus 5A. 14 will become 14I. This is how you get. Okay. This is how you get. All right. Okay. Clear? So this is a bigger procedure to get over here. What is the smaller procedure? Do this. Okay. All right. Clear? Do you understand this procedure? To get for a 2 cross 2 matrix, you can get a matrix polynomial like this if you know the trace and if you know the determinant. Okay. This is one method. By the way, if you know the roots of this equation, there is second method. Okay. Method number 2. If you know the roots of this, if you know the roots of it, so you can form a quadratic in it. Suppose somebody is telling you 2, 3 are the roots of this equation, and now you need to form the matrix polynomial. So what will you do? Okay, 2, 3 are roots, to lambda square minus 5 lambda. 2, 3 are 6 plus 6 is equals to 0. And now just replace it. So you will get A square minus 5A plus 6I is equals to 0. Okay. All right. Are we ready? Okay. So this question is from 2024 and this shortcut will definitely help you in this question. Are we ready for this shortcut? Are we ready for this question from 2024? Let me know in the chat box. Ready? Step by step we will do it. So in this question, what they are saying is this equation is having these two roots, minus 1 and 3. Minus 1 and 3. What does that mean? That means I have this equation, that is A square minus trace of A multiply A plus determinant A I is equals to 0. Or I have another method which is a square minus sum of roots, just like quadratic equation, times a plus product of roots times I is equals to 0. Okay. Now a square minus sum of roots. So 3 minus 1 will be 2a plus product of roots. So we are having minus 3 minus 3 minus 3i is equals to 0. Easy peasy? Yes? Okay. Right? Now, they are asking what? Sum of diagonal elements of A. That means they are asking me trace of A square. That's what they are asking. So can you see? A square is nothing but 2a minus 3i. So trace of A square will be trace of 2a minus 3i. Right? Now we can apply the property of trace. So trace of 2a. So this will become trace of 2a minus trace of 3i. And 2 will come out trace of a minus 3 trace of I. Trace of a. Can you see trace of a and sum of roots are equal? So trace of a will be equal to 2 only. Right? So trace of A is 2. So 2 multiply 2 minus 3 times trace of I. What is the trace of identity matrix? 2 cross 2. Identity matrix 2 cross 2. Who is going to tell me? 1 plus 1, 2. So 3 2s are 6. Okay. So over here, okay, trace of 3i minus 3i. Okay, so it will go over here plus. So it is plus. Sorry, it is plus plus. So plus 3 times 2. So can you see 4 plus 6 will be equal to 10. 10 is the correct answer. Right? Yes, trace is sum of the diagonals. And here are some properties of trace. So for trace, let me just write down the property. So trace A plus B will become trace A plus trace B. Trace 2a plus 3b. You don't have to find 2a plus 3b. 2 trace A plus 3 trace B. Yeah, 2a plus 3a. Corrected. Plus. Corrected. Okay, so always understand trace A is nothing but sum of roots and determinant A is nothing but the product of roots. Clear? This is 2024 question. I really liked this question. This is actually a new type of question, but they are asking this matrix polynomial since very long. This is something, the trace of A square. This part is new. This part they are asking already. Okay. All right, so we are done with today's session. We have covered each and everything, and this was all about matrices and determinants. But I would like to tell you something about VLC now, Vedantu Learning Centers. So many students are going to the Vedantu Learning Center and they are absolutely stunned and amazed by the facilities, the services Vedantu Learning Center is providing. So I would highly recommend all of you to visit VLC, Vedantu Learning Center, for the immediately, as soon as possible. And you can clearly see the contact number is given to you, right? Or what you can do is you can call or click on the link which is given in the description box right away, right now, and you can see on your screen that what all centers we are having. We have centers at Jammu, Bihar, Punjab, Delhi, Rajasthan, Maharashtra, Karnataka, then Tamil Nadu. Can you see so many centers from Tamil Nadu? And now I have learned Tamil. So Chennai, Coimbatore, Madurai, Trichy, Pondicherry is there. Then Andhra maybe also we are having centers, right? Odisha, Chhattisgarh we are having centers. So many centers we are having. And yes, I speak Hindi more often. Then the second language is English, and now I am learning Telugu and Tamil as well. Okay, all right. So now, yes. So what are those features? So students are going to VLC and they are actually like loving the Vedantu Learning Center experience. Why? Because now they are getting personalized attention from the academic mentor as well. So you are assigned a master teacher along with that academic mentor as well. And in the classroom, what you can do is the classes are absolutely going on the smart board, where you can physically just press the button of the remote and register your answer, and it will be displaying on your screen that, okay, suppose Index AP or Supriya has answered this question correctly. And one or more problem which all of you faces is doubt. Doubts is something like everywhere teacher is teaching, but if you're not clearing your doubt, it is not gonna happen. Things will not improve. So yes, three-way doubt support you are having. So 3 teachers will be will be clearing your doubts. Let me just show you how, right? So yes, your academic mentor will be taking, your master teacher will be taking, and online unlimited doubt support will also be there. Along with that, can you see that highest personal attention is what students are absolutely loving, along with high qualified teacher, great content, and rigorous practice sessions. Yes, rigorous practice session is the one thing which will actually make some improvement in your mock test or in your upcoming test. Okay, all right. I hope that this is clear, and absolutely, we are absolutely confident about our Vedantu Learning Center, about our curriculum, about our teachers, about the whole process, about whole thing, whole strategy, that we are guaranteeing that if you don't improve in your marks, you can get 100% fees refund. Okay, so over 98% Vedantu students saw increase in their marks, and if 2% are not getting what they want, okay, they can just get back their fees. Okay, all right. So these are the courses offered in Vedantu Learning Center. You can see for JEE, for NEET, for foundation. Let me just tell you about the JEE, because this is a JEE channel. If you are studying in class 12th, targeting 2024, so we are having test series and crash course. Start date you can see over here, it is 1st April and 11th March. Okay, so this is upcoming. Okay, and 11th to 12th moving students, that means 2025 JEE aspirants. So can you see long track weekend batch we are having, and long track weekdays plus weekends we are having. Along with that, 10th to 11th moving students, 2026 aspirants. So bridge course we are having from 11th March, and then long track after bridge course will be started 2nd April, and then long track weekend batches will also be starting 6th April. Okay, now for foundation you can see the dates and everything. Yes, okay, all right. Now can you see for Tamil Nadu especially, because I can see many students are from Tamil. Okay, Tamil Nadu. So can you see 12th studying, we are having yes, the similar type of thing, but the centers are at Anna Nagar, Chennai. Somebody was asking that where exactly is the center in the Chennai. Anna Nagar, Tambaram, Avadi, Velachery, then we have Coimbatore, Trichy, Madurai, all 3 centers over here. Can you see Andhra Pradesh and yes, so for AP and TS we are having Hyderabad, Guntur we are having 3 centers, Visakhapatnam and Vijayawada we are also having. So you can just check it out, and what you can do is you can just walk into the center and have some counseling, and then go back, speak to your parents, and then decide that what you need to do. How is your experience? Okay, all right. So you can ask for scholarship as well. So many things you can ask, and yes. So Vati Raidu is something which is happening in Tamil Nadu, and your favorite Shimon sir will be there. What you need to do is register now. Link is given in the description box. You can see that he'll be there in on March 19, 21, 23 and 24 in all 4 locations, 10 a.m. to 4 4 p.m. We'll be taking bridge course workshop. So for your siblings and your younger friends, you can just recommend Vathi Raidu, and for yourself as well. And yes, for people from, yes, Pune. So yes, Jeet Ki Raha is happening in Bhubaneswar, Pune, Patna and Delhi. And you can see that your favorite master teachers, Harsh sir, Pulkit sir and AKR sir will be there. And you can meet your master teachers in all these centers. You can see the dates as well, corresponding dates. Again, the link is given in the description box. Okay. So yes, this is all about today's session. I'll meet you super soon in upcoming session. This is me, Namrata, signing off.